Welcome, everybody. Thank you for joining us today. We are happy to have you here for the webinar on torque, force, and texture testing, how to elevate cosmetic quality standards. Before we dive in, there are a couple notes that I would like to share with you. Today's session is brought to you by Mecmesin, a proud member of the Physical Property Tester Group, a global leader in physical property testing. The PPT Group is also home to other amazing brands, including Lensman, James Hills, and Aluris. Together, we offer innovative solutions for testing tensile and comprehensive strength, torque, textiles, and the effect of shock and vibration, among other parameters. For more details about the group or any of our brands, please visit the PPT website. I shared the link in the chat box, together with a link to our events page, so you can keep an eye out for upcoming webinars. Now focus on Mecmesin. We have established technology labs across the US, UK, and Asia, dedicated to supporting our customers with educational, proof of concept, and demonstration testing. If you have any specific needs in physical property testing, our global team is at your disposal to provide the assistance you require. Let me introduce you to the team for today's webinar. Moses Da Rocha will be presenting, and I am Laura Calazans, one of the coordinators for today. Additionally, we have support staff and partners stationed across Asia, Africa, Europe, and the Americas, ensuring that no matter where you are, you have a local expert ready to support you. We are aiming for a dynamic and engaging webinar, so we encourage your participation through questions. Please feel free to submit any questions you have at any point during the webinar. You just need to use the question box. And at the end of the session, we will address all those questions. This webinar is being recorded for your convenience, and I will be sending the record after probably tomorrow. You will have that in your email box. So now, without further ado, I'll hand it over to Moses so we can start.
Thanks, everybody. Good morning, and we appreciate you all making the time to join our webinar today. As my colleague Laura just mentioned, we're going to be looking at quality testing in the cosmetic industry. Obviously, the Mecmesin in the PPT group offers several different testing applications in the industry. However, we're only going to be concentrating on two of them, essentially a force testing application and also a torque testing application. There's also some texture testing that's available. We'll look at all the different capabilities in the part of the presentation here. So our agenda for today is quite simple. First, we'll look at the importance of quality testing. Why do we even bother to test, right? And then we're also going to look at some of the types of product testing that our group has to offer in the cosmetics industry. And then we'll take a look at the two applications we have selected for today, which is the lipstick break testing and also cap torque testing on nail polish bottles. So, and then finally, obviously, we'll discuss some of the best practices for consistent and repeatable testing, how to establish a repeatable and consistent testing environment. And then obviously we'll take your questions. So we're hoping that this is going to be as engaging as we hope it would be. And let's jump right into it. So why is quality testing important, right? Why do we even bother? Sometimes you have a company that says, oh, you know, we've been doing this for 40 years. We don't really have to test. We trust our products, blah, 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 right? Well, for research and development, you want to determine the product viability, the strengths and the weaknesses of your products. And that's the reason why you test, because your brand is at stake. And also for quality control, for establishing those product standards that have been determined by R&D, and for the quality and the safety of the product. As we go along, you realize some of it is just going to be a matter of a convenience issue, and then sometimes it might be more of a safety issue as well. And then obviously once these standards or SOPs have been established, the information trickles down into production, where we look to maintain the product quality and safety that's established by the R&D and the QC department. And then often you may get supplies from your own suppliers when you're putting together your products. They'll give you these numbers and say, oh, on that product, we expect it to be that number. You test to make sure those numbers indeed meet the standards for which you have either set or that the supplier has actually set. So these are the different reasons why you test. And then product quality is not just a matter of convenience. When you under torque a product, it will, obviously either the product freshness is gone or it's going to spill if it's not properly torqued. And then if you over torque it, then you have to find a store to buy a torque tool or opening cap tool. So after you've bought your favorite cosmetic, you have to still go buy something else just so you can get into it, open it. Both of these situations, either the under torque or the over torque, essentially affects your brand. And you're always looking for that ideal torque. Essentially, for any product testing, you're looking for that, Goldilocks rule, the too much, too little, just right value, which is your ideal torque, which one makes protectionist and of the quality of the product, while also allowing your consumers to easily access it as and when they need the product. You see that in both the torque applications that we're going to look at, as well as the force applications we're looking at. If you look at lipstick, is it going to be, too soft where as soon as you try to apply it, it simply just shatters and breaks? Or is it going to be too hard where you literally, gashing your lip as you try to apply the product? Or is it just going to be just the ideal hardness, which one doesn't break and also gives you that fresh, smooth application that you expect it to have? So these are some of the reasons why you test. Again, these are the convenience reasons. There are also instances where you're looking at the safety, where is the product tight enough, right? So the little kids can't get into them. So I always use the example of the nail polish remover, which is alcoholic and it's a spirit. And yes, you want it to be tight enough where it's going to preserve the product quality. It's also going to be easy enough for the average adult to open it, but tight enough to prevent kids from easily accessing it. So at this point, you've moved from the convenience into more of a safety issue. And again, when your brand's reputation is on the line, failure is not an option. So these are essentially the reasons why you test. Now, quality testing in cosmetics in general, I did mention that it's more, we're testing both the product and the packaging, because either of those presents the same issues of quality or safety. So in much the same way as food is analyzed for its texture characteristics, the performance and quality of cosmetics can also be objectively tested, which we will see. And then the data that's obtained is used to determine customer expectations for touch and feel. Because if you've used a certain product for a while, you know exactly how it's supposed to feel when it's applied. So as soon as there is a deviation in that quality, you'll know right away. So essentially, quality control testing removes that subjective element when testing and delivers a reliable and accurate, repeatable results. We say that because in the past, it was more of a human just applying the product and going, yep, it's good. But these days, obviously, you do have more quantitative and qualitative ways of measuring your samples, so you can establish a more consistent and repeatable, instead of a more of an operator or a human dependent approach, which essentially introduces a whole ton of errors into your process, which creates issues somewhere down the line. So the consumer experience of a cosmetic product is inextricably linked with the packaging as well. So yes, you love the product, however, it's impossible to open the box. Once again, your brand is taking a ding, right? So testing is vital, so that the quality of the packaging also meets the same expectations that the actual product is supposed to meet. So these are the different rationales that you introduce into why you test in the cosmetic industry. So the different types of testing that you'll encounter in our industry here is, first, the lipstick firmness, some call it lipstick hardness, the container cap torque, which is a lot. There is also a container cap pull. And then there is a film peel strength testing. If you look at in that second row, the first image there where you peel the film, most products do have this now in different types of applications. There is an applicator strength. There is a flip cap strength, there is a pump actuation, and then obviously the pouch or the tube burst test. So these are all the different testing applications that you'd likely encounter in cosmetic testing. There are also instances where you might test the stickiness of a product or the cohesiveness of products. We're talking lotions and creams here when you go more into the texture field. Obviously, today we'll be talking more about force and torque. So the two applications we've selected for this webinar is going to be our lipstick break test, which essentially is lipstick hardness, lipstick firmness, as well as the container cap torque, which we're doing on the nail polish bottles. All right. So in the lipstick bullet break test, it's essential, as you know, the lipstick, this is not anything new, I'm telling you, if you're in the industry, but the bullet itself is formed by blending oils and waxes to create a molded solid to which your favorite coloring can then be added. The hard waxes will give the stick its strength, and the softer waxes help to bind everything together. So it's vital to control the formulation process to achieve a consistent texture that not only feels smooth on the lips, but it's also resilient enough to withstand being applied firmly. So these are all the issues we've discussed about, hey, we should be able to apply it without it just melting in our hands or breaking. And also, we should get that same level texture feel of smoothness when it's actually applied. So a key method to control the quality and consistency of lipstick is to measure its hardness using force testing, which we will see here momentarily. And this essentially involves clamping down the lipstick in a fixture and then applying a dull probe to push down on the lipstick itself. The reason we use dull probes is that we're kind of simulating, your lips are not sharp, right? So we're simulating the same thing you would do in real life, because when you use any sharp probes, it tends to slice or cut it, which does not truly represent what we're looking for in the results, the kind of data we're looking to collect. So dull probes preferable, which is fingers, lips, something that simulates that. So the amount of force required to break it determines its hardness, while how far the lipstick deflects indicates its brittleness. So two things you can measure in there, which is the force and then the deflection. This data obviously helps manufacturers to produce lipsticks that do not snap out of the container or melt or break or crack when applied, but then you still experience that touch and feel of the smoothness of the product. So without further ado, we will take a look at what that looks like. Let me share webcam here. Okay, so there we are. So there are still a couple of things that need to be looked at. Obviously, your tester or your system selection is you look again when we discuss the factors that go into establishing a consistent and repeatable environment. We'll look at your tester selection as being part of a larger environment, or it plays a larger role in establishing that type of environment. We'll discuss that. So again, you're looking to, more than anything, make sure that operators are doing the exact same thing at the exact same time each time. So let me also share my software screen here. So we've selected the software-driven test. Why? Because we're trying to remove the human element out of this as much as possible. So all we're doing is we're saying, you know what, we're going to go in, we want to run a new test. We're going to call this the lipstick test. Then click OK. This is obviously going to be a compression test. Click OK. This essentially brings us into our attributes. We'll go over to operations. For purposes of our demonstration today, we're going to just test in newtons and millimeters. These are all the different commands that you can use. Now, for most compressive testing applications, the test does not really begin until the probe touches the surface of the sample. You speed up the test, it breaks, you recoil, and then we're able to then measure the sample. So what we'll do here is first, we want to zero the value of load and displacement. We also want to run to that touch. So we want that speed to be relatively slow so it does not overshoot that. I'm going to put this at about 1/4 of a Newton. Again, it should be enough force to be detected by the touch, but not too much where it actually starts compressing. So that's what we're doing. And then the next thing we'll do is to run to a known displacement. Use the target. I just want to compress this about 20 millimeters, at which point I expect the sample to have broken. We're just simply going to go to, because it's in compression, we're going to enter a negative number, and then we'll increase the speed from 50 to, I'll go 150. And there we go. And then obviously that's the test. Once the test is completed, we do want the crosshead to return home, and that allows us to remove the tested sample, then put another one in. Now you can obviously test in different types of different units of measurement based on your preferences: ounces of force, grams of force, pounds of force, kilograms of force, and so on. We're going to be using newtons and millimeters. You can also choose inches, microns, and so on. And then obviously in the test results, in this test, we're only going to look at the break force, just that value. There may be other applications where you want to test the brittleness or the deflection. In this, we're only going to be testing the force. So in our standard calculations, we're only going to measure the max force, and I'm going to call this the break force. And we want to run this on a load versus displacement curve. We want to enable the results. And you also have the ability to run your results through pass or fail criteria, where you have a minimum and any value that falls below that is too soft, and you also have a max where any value that goes above that is too hard. So you can essentially limit your range of test results to your ideal break force value. You can do either this at the time of configuring the test, or you can just leave that open and do that after the fact to determine what's passing and what's failing. And that is our test. At this point, we just click exit. We want to save the test. That's okay. And then that newly saved test is going to show up here. That's our lipstick test. Now, you also, as you can see on my screen, based on the different applications we've done, you can attach a unique image to the test. So you can easily come in as soon as an operator logs in, they'll see exactly what they need to test, and all the operator has to do is just click that little button, and that should bring you into that live test mode. I'm going to change the contrast just a tad so we can see the traces better. All right, at this point, since we're asking the probe to return home, what I would probably recommend is we set whatever that home position is. So we'll go into tools, zero everything, just tear the displacement, and then we'll say, this is our home position. So at the end of the test, return to that home position, which will allow the operator to remove the tested sample, slide another one in, and then on and on and on and on. And at this point, we are pretty much ready to test. If you give me just 20 seconds here, I will prep the next two samples so we can test all three and then kind of talk through the test results. All right, at this point, all we have to do is just hit start. Probe is going to come down, it's going to touch the product. But again, as we said, just a bit of a touch, not enough to start compressing, just that touch. And then it's going to start, there we go. So at this point, test is complete. It's already failed. It returns home. All right. So as I said, we're going to test all three, and then we will look at the test results. So these fixtures are custom fixtures, and they can be customized to meet your exact product requirements. We just made this for purposes of our webinar here, so we can run through samples relatively quickly. All right, that's how easy it is to go from one sample to the next. And then we'll hit start. It's going to do the same thing. Come down, touch the sample, break, return home, and we'll put the last one in, and then we'll look at what those test results are looking like based on our selected calculations. So if you're ideally, obviously, when you're testing a batch of test samples, you're testing the same types, flavors, whatever you may call it. So that way you can have a more comparative analysis. But if also in your R&D department, you want to know how the actual coloring affects the hardness, then you can test all these different samples together to see how the coloring affects the hardness. If you look at just visually looking at the graph, will just give you an idea. As you can see here, that initial test was a little different than the second, and now we'll look at the third here. Excellent. So that's the whole enchilada. That's the test. So we have 3 test applications here. I am going to just kind of pause the webcam just for a couple, just so I can talk you through the test results. So if you look at visually, look at the screen, obviously it doesn't tell you much, but there is a tab for your test results that will tell you what the break force is. And so for sample number 1, now, if you click on that little icon, it will tell you, let me just change the contrast a little so you can see it. Say, hey, 7.2 newtons, that's the highest force before the sample starts to fail. That's where I'm seeing that for sample number 1. For sample number 2, I'm looking at about 9.1 newtons. That's when the sample starts to fail. And then for sample number 3, it's seeing about 6.5 newtons. That's where the sample fails. So when you're testing, instead of just using 1, 2, and 3, which really doesn't represent anything at all, you also allowed to make these annotations where we'll say, oh, no, you know, the first one was red, right? We'll save that. Sample 2 was, I'll just call this brown. Save that. And then sample 3, we'll just call that pink. So at this point, anyone looking at the test results can then say, oh, you know what, the first test was the red, whatever the, you know, you want to call it, whether by the name of the coloring, by the name of the product or flavor, whatever. So it's not just a bunch of numbers that don't mean anything, but you can annotate these so they do mean something. There's several options for exporting to a CSV file. If you want the raw data, export to Excel, email it to any number of recipients, create your own test report, or even send the results in the cloud to some customer somewhere that would like to see the test results for any batch of products that you're probably getting ready to ship them. Hey, would like to see the quality test on those. You can also send them into the cloud and have them downloaded, and they should be able to view it just as we're viewing it now. So that's a very simple testing application that will give you the results you're looking for as far as the firmness or the hardness of the product. As I mentioned, there are also additional calculations that you could have, things like area under the curve or the work if you're looking for more of a texture related results. And also in each of these test results, you can also now apply your pass or fail. So if we said we want every result to be between 5 and 10 newtons, for example, that will immediately give you the check mark. So once you've initiated your pass-fail criteria, all future and subsequent testing will immediately give you the check mark or the red X indicating whether the result falls within your range or not. As in, if it falls below your minimum, that's a fail, or if it goes above your maximum, that's a fail as well. You want to keep everything within your acceptable range for hardness or firmness. So I'm sure you guys will have all kinds of questions at the end of our webinar. So this is essentially what we offer for the lipstick firmness. As far as the nail polish torque, that's kind of a little bit different. So torque testing, I know a lot of us, if you're a driver or if you're into, you know, really into vehicles, when you hear torque, you're always thinking, oh, vehicle torque. No, this is essentially just the turning force, essentially, that it takes to open your favorite beverage or your favorite cosmetic. In this case, it just cap removal torque. It's simply just a way of determining how an object will react when it's being turned, as we mentioned. So the product inside the packaging is important. We want to keep the consistency and the quality and the safety of that. But if we can't even get into the product, that also poses a problem and creates the need to quality test even the packaging. So torque testing for most of these cosmetics you see in any given store that are packaged where you need to uncap to get into the product, it's definitely a way of determining during normal operation that it's going to open easily. But again, as we mentioned, it's also not going to open too easily where air goes into it and kind of, product goes flat, essentially. So a key element when measuring the opening and closing torque characteristics between a bottle and its cap or a container and its cap is to ensure, one, it's not too loose or too tight, as we've mentioned, just so it's just the right amount of tightness so you can access your favorite cosmetic product. The measurement is increasingly used by manufacturers as a quality control method to comply with industry standards. It ensures the proper functioning of components and serves to record their safety and fitness for purpose. So it can also help determine the root cause of a wide variety of defects, which can then be addressed in the production process to reduce costs and improve yields. So imagine if the capper on the line is not applying enough torque and the caps are kind of loose between where it's stored and on the production floor, it gets on a truck and gets into the destination, the store. It sits in the storage room for a few. By the time the consumer gets their hands on it, product's gotten too hard, the product's gone soft, it's gone bad, it's gone flat. There could be so many things, and the spoilage always obviously speaks to the bottom line, either at the production level or at the distributor level or at the on the consumer side of things. So it is a critical aspect of your quality testing to test your products. So if you all give me 20 seconds, I have to pull a bit of a switcheroo here to make sure our torque tester is fully functional. Okay, good here. Excellent, we're all set. I'm going to flip on my webcam here and get you guys a better look. So this is our torque tester. Now, again, same rules apply. What we're doing in this test is obviously to kind of simulate what you would do in real life. And as I mentioned, we are using just nail polish. So again, your favorite nail polish, once you receive it, you want to get into it and you do not want to fight with it just trying to get into the product. So the first part of the application, obviously, is to find a way to grip it on the bottom so it's not spinning or turning. So what we're doing, and we have different types of fixtures to meet different types of products. Obviously, this is not going to be the only product with a cap, right? So you and also when it comes to the top fixture, you'll have different types of caps. You have smooth, you have textured, you'll have serrated. Is it going to be glass? Is it aluminum? Is it plastic? So you have different types. So for any of these different types of bases and caps, the corresponding fixtures and accessories to make sure, as we mentioned, that the operators are doing the exact same thing every time to reduce the error in the process. So first thing we're using here is a base fixture that has a non-slip lining to pretty much grip the base so it does not slip as we test. So we're going to tighten that. And then the blue silicone pegs you're looking at are simulating fingers, because when you grip this in your hand, you use hopefully your fingers to open the cap. And then all we'll do here is essentially just drop that and then also tighten it, which simulates the grip on the product. And at this point, we are ready to test. So once again, I'm going to bring up the software and we'll configure a simple release torque test. So we're going to exit out of this. So as you can see, conveniently, we have a one-size-fits-all software that will do the trick. So the same one that will do your peel and adhesion testing, your coefficient of friction, all of that will also do your release torque and your application torque test. So I'll just take an existing test here and just make a copy of it. I'm going to use this on the Vortex Pro. And for purpose, because time here factor, so we want to make sure that I'll still walk you through it. We'll just pick an existing one. So this is going to be the nail polish cap removal. All right, and we'll go into operations. So everything is there. So all we're doing is running 360 degrees at a speed of 10 revolutions per minute. That's all we're doing in this test. And then we're measuring our results in Newton meters. You have other options, Newton centimeters, inch pounds, and so on. So again, your degrees can be revolutions or degrees. We're using degrees for now. And then obviously in the test result, we're measuring our breakaway torque. So that's going to be our max. Let me just trash some of these. That's all we need is how much force it takes to break the seal, so we can actually record the removal torque. So I'll just call this max release torque for now. Again, this is going to be on a torque versus angle curve. And for now, since we're not even sure what kind of results we're going to get, I'm just going to remove the verification here for your pass or fail. And that's it. I have report template number 11 selected. This is going to be, if we had to generate a test report that indicates, hey, we've tested this batch A, and this is going to customer A. You can also configure that test report and have it pretty much display everything you need to do. It's not playing well with me today. I'm just going to exit here and just run a few tests, and then we'll take a look at the results and see what that looks like. All right. Okay, so here we go. The newly configured test is going to be that nail polish cap removal. Once you click on it, it's a very similar interface to the one we just did. Once again, just going to change the contrast a little bit. We don't have to set a home because we go in 360 degrees. We expect it to return to the same position each time. And at this point, all we do is just hit the start button and just have it spin. There you go. End of test. So first thing we're going to do is make sure it actually did open. So loosen that. I'm going to lift it up. There we go. And then we'll make sure it did actually open. Loosen that. Going to bring it up. And as you can see, it did open. So sample number 2, clearly this is already tight. So we didn't do anything with it at all once we picked it up from the store. So we'll tighten that. We're going to loosen the crosshead, have it sit, then tighten that and hit the start button. I'm going to run that third test just to make sure this is definitely opened. And we'll put the third one in. That is still tight. Tighten that. Drop your crosshead. Tighten that little grip. And run sample 3. Once again, same manufacturer, but different product, essentially, different flavors, if you want to call it that. So these are the 3 tests. Once again, if you don't mind, I'm going to turn off the webcam so we can concentrate on the screen. So 3 tests completed, and here are our test results. So max release torque. Now, this is obviously showing the angle. We do want to see the torque. So let's exit. There we go. So that initial product, we saw about 7.4 inch-pounds of torque. And on the second one, we saw about 4.1. And then on that third one, we saw about 6 inch-pounds. So if you're a producer, you're asking yourself, all right, let's say we just tested 30 samples and the results are all over the place, right? You're asking yourself, why is that happening? Ideally, you want to test the product A altogether, 12 samples of those, product B, 12 samples of those, product C, 12 samples of those, just so you know if the capper is doing well on the line. So when you have, results that are only 20% good instead of 20% bad, you start to worry a little. One of the advantages that this particular tester can also do is if you have the actual standard that or the actual application torque that your capper is applying, you can use this tester to mimic that. Get a bunch of empty samples, run them to that application torque, and then run your release torque test. And anytime we've done that 9.9 out of 10 times, we see more consistency. So that immediately raises that red flag to say, hey, our pneumatic capper or whatever, the electronic capper is not applying uniform capping torque or application torque to all these bottles. So we need to take a look at it. And essentially, this is why you test. You want to know how consistent your product is. Because if you have a customer that wants all 3, they're happy with one because they can easily get into it and it's not hardened and flat because it wasn't closed properly. They're all perfect. But there are these other 2 that are just impossible to open. Growing up, I've had to use my teeth to open some of these things for my own mom. So I get the whole concept of too tight. And essentially, this is also why you test. So these are the test results. And you can, as I said, preview your test report. If I can get it to open here. I was having some difficulty. Oh, there we go. All right, so these are the 3 samples we tested. Obviously, there's no pass or fail criteria applied, but it will also give you a graph. And our software has that built-in ability to print this to a PDF report, which you can then share with your customer. If you wanted to put their logo on that right side and yours on the left side, you could do that at the point of configuring the test. So there's different options for configuring a nice looking test report, which you can then share. But as far as the test procedure itself, this is all there is to it. And again, this particular procedure will apply to different types of products that require cap removal torque. The only things that might change are the actual fixtures, the one that grips it on the bottom and the one that grips it on the top. And it could be anywhere from that sample that's small up to a gallon-sized sample. And there are also options for doing child-resistant closure systems, the push and pulls, the tilt and pull, twist and pulls, all of those that are more sensitive, that requires a little bit more to prevent infants or children from getting into the sample. So there are options. These are all options for quality testing in cosmetics. All right, let's get you back to our application here. So establishing consistency and repeatability in testing. All right, so these are the key factors that help you establish that consistency and repeatability in your testing environment. First, define the test objective. just like anybody. If you're taking a trip, you want a destination, right? Why are we testing these nail polish caps? Is it because we've received complaints from our customers? Is it because just based on our own quality standards, it's too tight, too loose, whatever? Define the testing objective. Next thing is establish the testing standards and requirements. All right. So we know it's tight or too loose. We do want to test it. How are we looking to test it, right? Is there an existing standard we want to use? Or is there an ASTM standard? Is there an ISO standard? Is there a general cosmetic standard? So those are the kind of things that determine how fast you're running the test, how far you're running the test, what kind of data you're capturing from the test. All of that comes into the testing standard and testing requirements. And then once those are determined, what kind of equipment do you need to actually run your test based on your testing requirements or your testing standards? So yes, in order to remove any human error, we don't want anybody guessing how fast or how far they're running the test, whether it's a force test or torque test. We want to make sure we have a machine of sorts that will determine consistently it's going to run at this known speed to that known displacement, known angle each time you hit that start button, and that takes all the guesswork out from it based on whatever the operator is doing. And then next, obviously, logically, now we have a tester that's going to give us those two critical factors in the test. What kind of grips and accessories do we need to not only capture optimal data, and usable data, but also make it easy for operators to run each test. From if you took 10 operators, we should make sure they all do the exact same thing the exact same way. So once you've determined those fixtures, all right, this is a glass base, it's a plastic cap. We're going to use, fixture A for the top, fixture B for the bottom. Next thing is, how do we tell all the operators to do the exact same things? This is when you determine your operating standards, your SOPs. Say, hey, we want you, and that includes how many samples you're testing, how the sample is fixtured in the top and the bottom, and even the environmental conditions. Because when it comes to lipstick break testing, if it's too hot, you're getting all these low values because it's so hot and the product got soft, right? If it's too cold, you're getting higher values because the product's a little harder because of the temperature, and so on. So you'll say our optimal temperature for testing this is between, let's say, 65 and 72 degrees. So we'll take 12 samples, test them all very quickly when we're maintaining that temperature to make sure all of our results are consistent. So these are all the different factors that go into establishing a consistent and repeatable testing atmosphere. And obviously, when all else fails, let's go back and look at, as I mentioned, in the case of the cap torque, why are all these numbers all over the place? Is it because there's too much friction on the threads? Is it that the plastic caps are cracking under torque? Or is it that the capper is not applying uniform torque? It's okay to go back and look at the processes or even the product itself, and you should be able to determine where any issues are coming from. So in a nutshell, again, I love doing this. I would have loved to show you every single application we have to offer the cosmetic industry. But if there is anything you would like to see, you'd like to send some samples, have a one-on-one with us so we can do a demo for you if you're looking to determine or establish your own testing environment. Please feel free to reach out to us. This recording will be shared so you can determine what you're looking to test, and we're here to help. We do offer product testing, again, as part of our sales process. So we don't like product test as a third party, but we'll say, hey, if you're looking to do this particular test, this is how we would approach it. We'll do a quick Teams meeting, put a webcam on it, show you how your samples look combined with our testers, and then you can then make the determination of how you want to proceed. And so without further ado, I'd like to toss this back to my wonderful colleague, Laura, for any questions. Back to you, Laura.
Thank you, Moses. This was really insightful. I really like all the different tests that you did today. Thank you.
You're welcome.
So we have a few questions, and if anybody else has more questions, please just put in the chat box. So let's go to the first one. So first one, you mentioned pill strength testing in your presentation. Can you give a couple of examples of this test?
Yes. So we do 180-degree peel testing. So if you think about the labels that go on your packaging, so we'll do an adhesion strength testing to make sure in the process of storage, transportation, and when it gets to the store shelves, that the labels don't peel off and it's just a mystery product, right, when it gets there. We also do the film that goes over your product. We do more of a 90-degree peel back there are several things we're looking at. Again, you're looking to preserve the freshness of the product and the quality of the product, and not making it impossible where it's going to rip in 15 different places when the consumer tries to open it. So we have different types of peel tests we do. And then there are some really weird ones out there, but whatever it is, we're here to work with you to find you a solution that works for you. Back to you, Laura.
All right, the second question, if you have several different sizes of foundation and lipstick, how do we go about testing them?
Oh, that's an excellent question. So the lipstick fixture you're looking at, and I may have to turn on my webcam again for this if you all don't mind. So the fixture you're looking at currently was designed for this particular fixture. So if obviously the different sizes for foundations and so on. So the way we design this is we make it almost like a gradient where you can accommodate different sizes. And we can make this, so I've seen some of these where you have like a little round hole on the bottom, you'd have a kind of foundation oval hole in the middle, and you can use one fixture to accommodate different samples, or you can taper it to fit from your smallest to your largest sample and so on. So all the screw does is just hold it in place just so you can actually compress and break the sample. So there are different types of fixtures, and if it's a really uniquely shaped sample, then obviously we can create custom fixtures to meet that application as well. Back to you.
So I have one question here. I don't know if you're gonna have that in hand, but can you present some grippers to Vortex?
Oh, um, so there's dozens of different fixtures that we use on the Vortex. So what you're currently looking at here is our universal fixture, which has the blue pegs. And I'm also
Sorry, you're not
using,
sharing your screen,
oh, I'm not sharing my
Moses.
screen. Of course not. All
No,
right, let me try the webcam again. All right, so
share
we're
your webcam.
using
Yes, here we go.
the universal fixture on the base, and we've just created a couple of adapters to fit that particular sample perfectly. But we're using that on the top with the blue silicone fingers, again, to prevent it from slipping as you apply torque. There are several different types of fixtures and applications we use. I did mention that if your sample has serrated caps, for example, we could use a chuck that we attach to the sensor, and these have a molding that meets perfectly the serrated caps. So when you drop that crossset, it comes and essentially mates with that, and you're able to turn it without having the operators tighten or doing anything. All they do is drop that top, it comes down, sits perfectly on it, and then obviously you'd have a base that fits that particular diameter as well. So they're different. Oh God, we'd spend another hour just going through all the different fixtures that are available for the Vortex. If from that question, it sounds like you own one. If you could reach out to me directly, we'd work together to find you a fixture that just works perfectly for you. I do have these little adapters. It's a V-groove. What we do is we line them with a non-slip, essentially call it a cat tongue. It's a self-adhesive label that goes in there to prevent the base from slipping. Now, this was made for an eye drop product, so it's very small. So we attach these to that universal base fixture just to give us more of a consistent grip at the base to prevent the samples from slipping. So yeah, happy to work with you to come up with some fixtures that will work.
Great. Let's see. We have a couple more questions for you, Moses.
Okay, sure.
We make nail polish remover, which requires push and turn to open the cap. Can we test this too?
Can you say pressure? Can you repeat that for me? I'm sorry.
We make nail polish remover, which
Okay.
requires push and turn to open the
Okay.
cap. Can we
Oh,
test this
perfect.
too?
Yes, 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 and yes. So the container I just showed you with the serrated cap, that is actually a push and turn product, which we use the same tester for. So for the push part of the test, there is a cap at the top of my tester here. Oh, not showing my webcam, am I? Let's try that again. There we go. So that cap you're looking at on the top essentially simulates that push to push on. So this is the container I was talking about. This is actually a push and turn container. We molded the cap for it to give it that flat base that will actually apply the push. And then what we do at the top is we put in a known load. So this is a certified load or certified weight or mass, which we essentially just put on the top. And that simulates the push part of the test. And then we obviously run the torque to capture the data. Because this is certified weight, this is 3 kilograms, it's about 6.6 pounds. We know this is exactly how much torque force is required, the axial force required, and then obviously based on the ideal amount of force required to engage the mechanism for the CRC or child resistant closure, we're then able to turn it and measure both values at the same time. One of the things we do is, again, usually based on experience of what we've done in the past, we're able to tell whether the axial force is going to be, again, even the Goldilocks rule applies. Is it just the right amount of force? Is it, if it's too little force, obviously it's just going to click, 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 and not open. If it's too much force, it's going to crush it and spike your actual release torque values. And if it's the right amount of force, then obviously it's going to open the cap. So yes, we can definitely test the child resistant closure caps as well. Back to you, Laura.
Awesome.
Sorry.
We have one last question.
Sure.
Can we just test our products by hand instead of computerized systems?
Oh, yes, of course. The question, as I mentioned, is we have handheld instruments that will test your products. Again, how much is your brand worth, right? Or are you just not worried about just the annoyance part of it, or is it a safety part attached? So we're talking about the CRC test or the child resistant closure test. As the name implies, this is more of a sensitive test. Is there a simple tabletop handheld test that you can just push and turn and then measure the release torque? Yes. But by introducing something that takes the human element out of it, you're establishing a more consistent and repeatable testing approach that will take any issues that will create future liability out of it. But yes, there are simple instruments. There is a simple handheld force gauge that will fit right in your palm that you can just push on the lipstick and break it and then measure a force. Now, if you took 10 people, everybody would have their own concept of how fast they're running the test and how far they're pushing it. You push it too far, you might have a higher value. You don't push it far enough, you might have a lower value. So your data might be all over the place. But yeah, there are instances where, hey, listen, either because of budgetary reasons or reasons of convenience, we have a sample that we just can't fix fixture on a tester. You might decide to go with a simple handheld instrument. You obviously could do that. We do have those as well.
Well, those are all the questions we have for today, Moses. Thank you
All
so
right.
much
You are welcome.
for
Thanks,
sharing all
everybody.
your expertise with us. And
All
thank you,
right.
everybody who's here. If you have any questions, please don't hesitate to send your inquiries to Moses or to info@mecmesins.com, at mecmesin.com. And we're excited to see you in future webinars and continue this journey of learning together. So until then, take care and thanks
Thanks,
again for
everybody.
your participation, and thank you, Moses.
Thank you.